This is chapter 8 and 9 review, and this is page 2. We're going to start with this truth table. Now, we really hadn't made a truth table this big before, but it actually doesn't matter. It actually makes it easier, to be honest, to get all these other columns. Before, what we saw was maybe something like this, like four columns at max. But we can actually just keep going and get these other columns, because some of these other columns will help us, like the not P, not Q will help us with these two, and things like that. So although this looks kind of big and scary, it's actually not too bad. We have to remember what the rules are for each of these operations, though, and what they do and what they mean. So the first one is pretty easy. It's just the little swooshy guy. Okay, that means negation. And sometimes we call this, we say not P, or it's the opposite truth values of whatever P is. So if we look at the P column, which is right here, we just want to take this column and put the opposite truth values right here. So opposite of true is false, right? Opposite of true is false, opposite of false is true, and opposite of false is true. That's it. We just take the P column and we negate it, or switch the truth value to the other one. Not Q is the same idea. So this time we look at the Q column, and we need to negate this column. So the opposite of T is going to be F, opposite of F is going to be T, opposite of T is going to be F, opposite of F is going to be T. Okay? So that's pretty easy. This guy right here is the symbol for AND. Okay, which is also called the conjunction. So to get something, two statements to be true, to have a conjunction be true, an AND statement, both of the statements have to be true. So in our class, we did an example of like P was like I'm taking a math class and Q was taking a computer science class. The only way for P and Q to be true is if both P and Q are true. So I'm taking a math class and I'm taking a computer science class. Both of those are true, so the statement I'm taking a math class and a computer science class is a true statement. Okay, here you're taking a math class but not a computer science. So you can't say that you're taking both. You can't say I'm taking a computer science class and a math class because you're not taking this one. Same thing here. Here you're not taking math, but you are taking computer science. Well, you still can't say that you're taking both. And here you're not taking either. So that's how an AND works. When you have an AND, you're only going to get one true. And you're going to get that true when both of the statements are true. Okay, this little symbol is for OR, also called the disjunction. And an OR is true when at least one of our statements is true. So if we want to make a little note here, let's make it down here. I'll say true when both statements are true. That's pretty little. This one right here, the OR, this is true when at least one of these two statements is true. True when at least one statement is true. Okay, so when you have this is what we call like a compound statement because it's made up of two other statements. You have to look at both of these. So this is a statement, and this itself is also a statement. It's just a compound because it's made of two. So when we say true when at least one statement is true, we're talking about these two that make it up. So when one of these is true, at least one, then this is true. So is at least one of these true? Yep, they're both true. Is at least one of these true? Yep. Is at least one of these true? Yep. Is at least one of these true? Nope. Okay, so that's your OR. All right, the next four are all what we call conditional statements. When you see that arrow, okay, that's a conditional statement. And conditional statements are mostly always true. The only time you're going to get a false is when you get a T going to an F. So I'm going to make a little note here. F if T to F. All right, that's a little confusing, but we'll kind of explain as we go. These are the contract type problems. So, the contract idea was if you have a contract with somebody and they promise to do something and they do it, and then you don't pay them, that's the problem. Okay, so let's look at the letters tell us which two columns to look at, and then the arrow tells us what direction. So P and Q, we're looking at the P column and the Q column, and we're going from P to Q, and we're looking for a T to an F. So that's a T to a T, so we're good. Okay, that's a T to an F, so that's a problem. Okay, F to T, that's fine. F to F, that's fine. Okay, so if we talked about mowing lawns and babysitting and stuff. So this would be something like we use Tanner as an example. If Tanner mows my lawn, then I will pay him $20. Right? That's what this statement would be. If Tanner mows my lawn, then I pay him $20. So this is Tanner mows my lawn, I pay him $20. Everything's good. This right here is Tanner mows my lawn and I don't pay him $20. Well, Tanner fulfilled his end of the bargain and I didn't pay him, so this is like a contract that got violated, and so we say false. Okay, here Tanner didn't mow my lawn, but I paid him money, but that's okay. That didn't violate any contract because since Tanner never mowed my lawn in the first place, I never owed him any money. So if I want to give him $20, that's fine, but there's no contract violation here. It seems kind of weird, but this is still true because no contract was violated. Okay, this is Tanner doesn't mow my lawn and I don't pay him, but that seems kind of normal, so no contract was violated. All right, that's what we got going on here. So that's kind of the review of the conditional statement. It's like a contract, okay? Now, when you see different kinds of conditional statements, like Q implies P, this just tells you we'll look at the Q and the P column, but go the other direction. And again, all we're trying to find is a T to an F. As soon as we find a T going to an F, we say false, and then everything else is true. So this one, just so we know, is called the converse, right? Because if we switch the order of the hypothesis and the conclusion, that's called the converse. So we're going to look from Q to P, okay? All right, so here's Q, here's P, we're going this direction. So T to T, that's fine. F to T, that's fine. T to F, okay, that's the one we're looking out for. So that one's got to be false. The other two are true so far. And then we got an F to F. That's true. Okay, no problem there. All right, the next column, this is the inverse. So notice it's not P to not Q. So there's like a P at the beginning, a Q at the end, but we're negating both of them. And so this tells us, look at the not P and the not Q columns. So instead of looking at these two, now we're looking at these two right here. Okay, and we go from the not P to the not Q column, so we're going in this direction. And again, we are looking for a T going to an F. That's the problem. We're looking for a situation where Tanner mows my lawn and I didn't pay him, and we're going to say that's the contract violation. So F to F is fine. F to T is fine. Uh-oh, there's our T to F. Okay, that's the issue right there. False. Okay, and then we got a T to T, which is true. Okay, notice that these two match. The converse and the inverse have the same truth values, which is kind of interesting. And then for our last one here, we are going to look at not Q implies not P. Okay, so again, we need to look at the not Q and the not P column. So here's not Q, here's not P. And we want to go in the direction from not Q to not P. So not Q to not P is going to go this way. Okay, so we have an F to T. That's true. Remember, we're looking for the T to F. That's the false guy, the T to F. Okay, T to F. Okay, there's your problem. F to T is going to give you a true, that's fine, and then T to T is going to give you a true, that's fine. Notice that the original statement and the contrapositive have the same truth values, T, F, T, T. And this one, again, was the contrapositive. Contrapositive is when you take the original statement, you switch the order of the P and Q, and you negate both. Which is a great segue into the next section here. So we have a conditional statement. If I don't have homework, then I'm going to the park. And we're just going to label this hypothesis as P and the conclusion as Q. So for a converse statement, we take the P and the Q and we switch the order. We say Q implies P. Okay, so we're going to start with this one. We're going to start with if I'm going to the park this weekend, or if I go to the park this weekend. then I don't have homework, or I didn't have homework. Okay, now let's assume that this is true. Let's assume that that was a true statement. Maybe it's not, but let's assume it's true for a minute. The converse is not necessarily true just because the original statement is true. And that's also true of the inverse. So when you see something that's just like the order switched, you can't assume that it's true just because the original was true. And we kind of see that when we talked about detachment and syllogism. So that's an important concept. Okay, let's do the inverse. So the inverse is not P implies not Q. Okay, so not P is the opposite of this. Now this is kind of weird, and this is, if you were in on the meeting, Ella pointed this out, which was a good catch, good observation. This is going to be weird. We have to negate I don't have homework. So it's like not I don't have homework, or I don't not have homework, or whatever. So that double negative becomes basically kind of like a positive statement. So we would say I have homework. So it would be if I have homework. That's the negation of this. The opposite of not having homework is having homework. Then we negate this one. I'm not going to the park this weekend. Okay. Okay, and the contrapositive is kind of both put together. So not only do we switch the order, we also negate them. So not Q implies not P. And you can see that those are the same up here, right? The original, converse, inverse, contrapositive. Okay, so we can either take this one and negate it, or we can take this one and switch the order. But it's going to look like something like this. If I'm not going to the park, this weekend, then I have homework. Okay. So if I'm not going to the park this weekend, we start with this one and we negate it, then I have homework. That's the contrapositive. Sometimes it's kind of hard to tell if a statements are going to be true or not. So the reason why these structures or these patterns are important is because we can just say, as long as it follows this pattern, we know something about it. The contrapositive and the original statement always have the same truth value. You can see that up here in the truth table, right? They both go TF, TT. So whenever this is true, this is true. And whenever this is false, this is false. So sometimes if you were to just read that, and it kind of sounds backwards, right? You're like, if I'm not going to the park this weekend, then I have homework. Is that the same thing as this original statement? And you're not sure. You can just look at the structure and be like, okay, well, this is the contrapositive, and I know the contrapositive is always true. So even if this kind of sounds weird or kind of backwards, or there's, it kind of sounds strange, we can tell that it's the same as this one, just by its structure. Okay, next two are pretty quick. They're just basically picking out deductive reasoning. So in the class lesson that we did, we had on the board, I had two different sides of the board, and one was the deductive reasoning side and one was the inductive reasoning side. And the deductive reasoning side, our example was the detective or the lawyer. Okay. Also, deductive reasoning goes from general to specific, and that's this guy. When we use rules, facts, definitions, or like the way we do it in our axiomatic system, we use postulates, we use theorems that are already proven, we use definitions, and we put them together and we construct this chain of reasoning. We use doing deductive reasoning. We do this chain of reasoning and we reach a conclusion going from general facts to a specific conclusion or a specific case. That's deductive reasoning. That's our detective. Okay. This one was like the weatherman. The weatherman observes the data. He looks at all of the past weather patterns, and he tries to find those patterns and extend those patterns, and he makes educated guesses or predictions about what's going to happen in the future based on what he's seen in the past. And that is inductive reasoning. So finding patterns, extending those patterns, making conjectures, that's inductive. Basing your reasoning on logic and definitions and going through a chain of reasoning to reach a positive conclusion, going from general to specific, that's deductive reasoning. This goes from specific to general. Specific cases, specific data, and you're like, well, let me generalize that pattern and see if that pattern holds. So that's just something you gotta know about inductive and deductive. Okay, that's page 2. We're gonna come back and do page 3 in the next video, so check that out.